Hi all there. My name is G. Tilak, working as an assistant professor in Mechatronics Engineering Department at Hindustan College of Engineering and Technology. I'm here to talk about the programmable logic control, the basic of PLC, the architecture of PLC, and the fundamentals of PLC, which can be used in industrial automation. Well, talking about industrial automation and control. PLC plays a vital role in controlling all the devices which is being used in an industry, especially when it comes to manufacturing processes or any assembly lines or controlling robotic devices or any activity that requires precision, high reliability control. And talking about PLC, the programming in PLC is very easy, and fault diagnosis is also becomes very easy when PLCs are used. And it was developed in the automobile manufacturing industries initially to provide flexible and easy programmable controllers that could replace hardwired relays, timers, and sequences. So let's see the next slide. So this slide shows you about the block diagram of a PLC, and you could see a PLC with inputs and output signals. The input signal is given to the PLC device, and the output signal is taken off from the PLC for doing some work or to actuate the actuators. And these things are done automatically by feeding a set of instruction to the PLC. So this is a kind of simple understanding of PLC, and if you could look into this figure, you could understand what is all about PLC. So let's get into the next slide. Okay, this slide shows you the PLC architecture, where there's a kind of devices which is clapped together to form the architecture of PLC. So, to be very precise, I would say all the devices are connected or interconnected for that matter to do some processes. For example, the PLC, the PLC as a power supply, and that power supply is given to the CPU, that is central processing unit, and where you could find the input module and the output module, which is interconnected with the CPU, and you have a memory where all the data is being stored, and the processes is carried out by input devices which is connected with the input module, and the output devices are connected with the output module, and there's a programming terminal where the set of instruction is being passed in and out of the the CPU. So this is the simple schematic representation of the architecture of PLC. So the PLC has an important part called as CPU. The CPU is the brain of the PLC, and it consists of several devices that could perform a specific functions, uh, namely the microprocessor, memory, input-output circuitry. The CPU actually controls and processes all the operations within the PLC. It is supplied with a clock signal with a frequency of typically between 1 to 8 megahertz. This frequency determines the operating speed of the PLC, and it provides the timing and synchronization for all the elements in the system. So this diagram shows you how the information flows. The information is actually converted into digital signal format, and it is being passed across with the help of communication buses. So now talking about a bus. A bus is just a number of conductors along which electrical signals can flow. So it is a ribbon cable like structure which runs across uh, the PLC. Especially the CPU uses the data bus for sending data between the constituent elements. And there is another bus called as address bus, which actually sends the addresses of location for accessing stored data. And there is another bus called as control bus, which actually used for signals relating to internal control actions. The system bus is a kind of bus which is used for communicating between input output ports and the input output unit. So this slide shows you the PLC um, and some of the PLC manufacturers, Siemens, Rockwell Automation, Allen Bradley, Mitsubishi Electric, Schneider Electric, Omron, Emerson, Kianci, IDEC, Misang PLC. So this slide shows you how a PLC works internally. So this diagram shows a clear picture where the PLC has different types of devices clamped together, and the functioning is done with the help of all these devices. So the first device will be like communication module or RAM, CPU, input output modules, and EEPROM. So the CPU is connected with all these parts so that it controls all these parts of the PLC to get the output in an appropriate manner. So you have a power supply to actuate all these uh, parts of the PLC. So the power supply is taken from the power cord, and in turn you have a power supply to the power cord from the machine which is connected with the PLC. So this machine has input devices and output devices. The input devices gives the signal to the input modules. The output devices get the output signals from the output module of the PLC. So this actually is controlled by the program which is fed into the PLC. So it depends upon the application and what the mission can do is decided by the program which is being fed into the PLC.